Perfect. So allow me to bid you the official good morning. Welcome to the Manager Learning Series number 6, Managing Containerized Application. My name is Jean-François Bilodeau, or JF, whatever works for you. Before we jump into the seminar, there's a couple of things I'd like to set up for you guys. Let me jump right in. You should be able to see my screen right now. You should see the welcome slide. If not, please let me know. But as we go through the seminar, we've got 3 good hours to spend together, explore what are containerized application and how do they provide value to us as manager. And if you're not a manager yourself, you might be a team leader, you might even be somebody who works in IT, somebody who works in IS. It's not important. What's important over here is I do want to make sure we understand where and how containerization delivers value to the way we do things, and some of the changes you may have to consider doing to help us move towards containerization. So these are some of the things I like to do for you guys as we carry along. So to get us started over here, well, if you have any questions as we carry along, just so you know, I don't have a fixed formal schedule for the next 3 hours. So if you guys have any questions, even if it goes a little bit outside the scope of the official curriculum, let me know and I'll do my best to address that for you guys. So at any time, you can drop a message in a chat window, you can drop a message in the question window. I may not get to it immediately, but I'll make sure to get to it as we carry along. Slides, there's not much, but they will be made available to you after the presentation. And more importantly, this seminar is being recorded. So if you want to watch it after the fact, or you'd like to share it with some of your coworkers, not a problem. Do take advantage of that. We'll send all of that to you once we're done with that seminar. So let's talk about what I'm hoping to cover with you guys as we move ahead. First thing I'd like to do is talk about what is containerization. All right, demystify that. Even if you're already familiar with containerization, excellent. If you've got some superficial knowledge, I do want to make sure we're all at the same level. Let's eliminate common misconception, misunderstanding as to what containerization is. And if you're completely new to it, well, let's understand what that's about, since that'll be the topic of our discussion. Then we're going to talk about moving towards a process-based development and operation. What I mean by that over here is this is not really a requirement to take advantage of containerization, nor is containerization going to move you to a process-based development and operation process, but I think you'll see the two will actually fit in together quite naturally, hand in hand. And finally, this is going to be the bulk of our discussion over here. Let's talk about using containers in development, so your development team can take advantage of that. We'll talk about at least 3 ways by which they'll take advantage of that. Let's move into testing with containers and how they can assist us with that. And finally, let's get into production as well. And how do we manage containerized application in production from both a business perspective as well as a technological perspective. So a lot of good stuff coming up for you, but as I said earlier, as we carry along, if any questions comes up, any comments, drop them in the chat window, drop them in a question window. I'll make sure to get to them as quickly as possible. So moving ahead, let's talk about what are containerized application. Actually, even before I talk about what are containerized application, it might be useful to talk about where containerized application came from, what need drove the development of containerized application. All right, they did not emerge out of a vacuum, and the concepts that we are going to look at over here are not new. We can go back all the way to the 1990s, maybe even the 1980s, and see the idea of containerization already being put in place in production by different organizations using different technology. Not quite the technologies we are going to look at in this course, but It's not a new idea. Originally, the idea behind containerization was to isolate an application, a process, I'll use the term almost interchangeably, a process from the rest of the system, right? Similar to what we do today with virtualization. I'm assuming most of you, if not all of you, are familiar with virtualization, running virtual machine. If we can discuss that a little bit visually, when we talk about virtualization, we're talking about having one host operating system, Windows, Linux, whatever you want, and on that host running a series of virtual machines, which themselves are their own operating system. They run their own program, whatever we want over here. And one of the value behind virtualization, of course, is isolation. I can bring up a machine with little to no hardware configuration. The host takes care of that. Once the machine is up and running, typically I'm going to install, configure one application on it, a web server, a database, a whatever I need to use for my environment. And from that point forward, it runs in isolation. I control network access to the machine. I control memory. I control CPU. I control any resources associated with that machine. And again, one of the beauty over here is that directly between two VM, there's no mechanism between by which VM1 can interact with VM2 over here unless we provide that mechanism. We provide a bridge, for example, a network bridge between the two. So that's virtualization, which is a form of, you could say, containerization, but not in the sense that we're going to look at. Furthermore, when it comes to containerization, one of the initial goal behind containerization, well, was twofold. Security, all right, by isolating a VM from the rest of our system or a containerized application from the rest of our system. One of the idea over here is if that application gets compromised, it becomes more difficult to compromise the rest of the application, as opposed to if I host application traditionally, as we're doing on older server, as we might do in older mainframes, that sort of thing, where I might run directly a whole bunch of applications over here on the same machine. These are my application. If one application gets compromised, well, the application, whatever the application can do, whoever compromised it can do pretty much as well, including start to access and compromise other applications. So we don't have that isolation in a traditional runtime environment. With containerization, we have that ability. Another traditional value proposition behind containerization is the idea of stability, right? In the sense that if an application misbehaves for whatever reason, because it's isolated from the rest of the system, ideally it should not impact other applications that are running on that same system. Same thing with a virtual machine. If a virtual machine starts to misbehave for whatever reason, goes down even, it should not bring down the other machines running on that same system. So it does also provide stability. So these are two traditional values behind isolating application. And the two approaches, the first one I'll refer to as jailing as in putting an application in a jail. That would be a bit of a precursor to modern containerization. And the other approach that most of us are probably familiar with is virtualization. So let's go. Why do we need containerization then, right? If we already have those wonderful abilities. Well, there's a couple of things to consider when it comes to well, let's begin with jailing. I'm not going to spend a lot of time on that. It's not terribly difficult to do, but requires a bit of specialized know-how. All right. Again, a little bit of training, a little bit of practice, shouldn't be too much difficulty, but jailing usually needs to be done on an application by application basis. In other words, once I've jailed application A, I've created a jail for it, I need to create another jail for application B. And those jails are not portable generally. When it comes to virtualization, you've got added advantages, right? Now it's much easier to set up a virtual machine. Couple of clicks with Hyper-V, VirtualBox, VMware, whatever you want to use, you can bring up a virtual machine very quickly, very conveniently, much easier, much less specialized knowledge necessary than what we had with jailing. Another advantage that we have with virtualization is that it's also much more consistent when it comes to managing our virtual machine. So what's the drawback behind virtualization? Well, there's a couple of things to consider when it comes to virtualization. One, well, I'm going to call it constraint, is the weight of the virtual machine, in the sense that if I can, I was about to say zoom in and I accidentally zoomed into my machine over here, but if we can look at it this way, one thing to consider over here is that there's a couple of moving pieces that I did not include in my previous diagram. We have hardware, and then we have our host operating system. And normally on top of that, we would put the hypervisor layer, but I'll leave this one aside from that. And from there, we can slap on a couple of VMs. But here's the part that I really want to get into when it comes to those VMs. Those virtual machines also run their own operating systems, Windows, Linux, whatever you want to run over here. It's not important. And on top of those operating systems, you need to run the user space. In the Unix world, you would call it the user space. In the Windows world, it would be the user environment. And finally, on top of that, you would want to run whatever application you need to run on top of that. And by application, I'm talking about things like, let's say, IIS, to host a web application in Windows. It could be WebLogic, WebSphere, Tomcat, Wildfly in the Java world. It could be Apache. It could be Nginx. If I want to do this in maybe a reverse proxy type of architecture, and if I'm getting into microservices type of architecture as well, if I'm running, let's say, a .NET application, a .NET Core application, ASP.NET Core, if I'm running a Spring Boot application, a Node.js application, of course, I would need to run those applications. And before I can run any of those applications, another thing to consider over here is I need to set up the VM as well. I need to install the operating system, configure the operating system, harden the operating system, and also it becomes an operational overhead. I need to update the operating system, patch it, and monitor it, back it up, whatever I need to do. So that's a long-term investment in that virtual machine. And once this is done, I also need to worry about the runtime environment. All right, if it's a .NET application, I need the .NET framework, core or otherwise. If it's a Java application, I need the JDK. If it's a Node application, I need Node.js installed. And finally, then I am able to run my application. But again, consider the fact that all of these VMs become operational overhead. Who's responsible for managing and maintaining the operating system, the runtime environment, and whatever peripheral elements in here? We are. Our organization is. All right. And I keep that in mind because we'll come back to that concept as we carry along. Another thing to consider over here as well is licensing costs. Right? If those machines over here, just as an example, are running Red Hat Enterprise Linux, they're running Windows, there's licensing costs behind those machines that I need to take into consideration. Is there any way by which I could reduce my licensing costs or free those licenses for other use? Well, of course, that is coming up as we carry along. So let's put that aside for now and let's talk about what is containerization. And some of you may be well aware of that, but again, I do want to make sure we're all at the same point, since, hey, that's going to be essential for our discussion as we move ahead. So what do we mean by containerization? Well, in a nutshell, what we are talking about is kind of sort of the same ideas to what we explored over here. I've got my host operating system, and on top of that, I want to run a couple of applications. Now, of course, those applications could be run in a virtual machine. That's okay. But the thing to consider over here is I've got a couple of applications. If I run them in a virtual machine, well, there's additional weight. Actually, that's one thing I did not mention as of yet, but between VMs over here, there's really no resource sharing. Memory is dedicated on a VM by VM basis. Disk is dedicated on a VM by VM basis. In the sense that, for example, if I were to install the JDK, Java, whatever version over here, to run a Java application, a Spring Boot application, and let's say I need the same JDK over here, I need to install the JDK twice. Now, some of you might say, well, JF, why install it twice? Create a base image, install the JDK, use that base image to create both VM. And sure, yeah, I'm no problem with that. But remember that when you start your JDK, you're using up twice the amount of RAM, you're using twice the amount of disk, and also operationally, that means that there's now 2 instances of that JDK I need to manage. So just keep that in mind as we carry along. So when we get into containerization, what's the difference between virtualization, or what's the difference between just running the application as is on the machine locally? Well, virtualization, or containerization, I should say, does take advantage of virtualization. So there is a hypervisor, hyper, would help if I knew how to spell. Start that over, hypervisor involved. But the difference over here is we're not going to virtualize the entire environment, the entire operating system, I should say. We're just going to virtualize. We're going to use virtualization to contain the application, encapsulate, if you want, the application we're going to run over here. So we're going to take advantage of virtualization to create a fully isolated, fully controlled environment in which that application over here runs. That's the first important point over here. One benefit that we gain over here is we don't need an additional operating system. Right? My application, when the application over here needs to talk to the operating system, well, it's going to go through the hypervisor and eventually hit the host operating system, the host kernel to be more precise, assuming the hypervisor allows it. So there's one kernel install, one operating system install, less overhead. More resource sharing, but that's something I want to come back to as we carry along. But you still get the benefit of isolation, in the sense that fundamentally, from the perspective of all those applications, they each have a dedicated disk. Just like my virtual machine each have a dedicated disk, they each have their own dedicated disk. Meaning that if, let's label those, this will be application A, B, and C. If application A writes a file or modifies a file to that disk over here, well, application B does not see that file. And of course, the same applies for application B. If application B modifies something, application A does not see it either. So isolation. Same thing when it comes to the network. Same thing when it comes to all the resources on the operating system. From the perspective of application A and application B, they don't even see each other, right? If application looks around and see what else is running beside me, nothing. I can even show that to you, and I'll demonstrate that later on to show you that from the perspective of containerization, it's as if that application is running by itself on that machine. All right, even though we're not using a virtual machine. And this, another advantage that we get when it comes to this is better resource usage as well as resource sharing. Okay, so that sounds kind of neat over here, but is there any other reasons why I would want to consider a containerization? Well, another facet that really helped containerization explode in popularity. Right? Containerization is not a new idea. It's something that's been around for maybe 30 years, but the popularity of it has exploded recently. Why is that? Well, one of the prime reasons is thanks to a little piece of code called Docker. Most of you probably have heard of Docker. Some of you might even be using it right now. There are alternatives to Docker, but realistically speaking, it's by far the dominant containerization solution. You're welcome to look at alternatives, but the reason why Docker is so popular, it is the dominant resource out there, is for a number of reasons. One of the reasons is rich ecosystem, which I'll talk about. That will be essential for us to take advantage of containerization, but a massively rich ecosystem that's unparalleled by any other containerization solution. But I like to think that one of the things that really helped Docker take off in terms of popularity, not necessarily the only thing, but one of its key selling point is that those containers, the way to look at those containers over here is that, let me actually look at it from another perspective. The important part for us over here is we need to recognize that for an application, whether it's an application that was developed on-prem or third-party cloud solution, it doesn't really matter. For that application to deliver business value, we need two things. We need code. All right, compile code at a minimum, but if it's an application that's being developed or tweaked in-house, we of course need code. If it's an application that comes from a vendor, then we need, of course, compile code that we can run. All right, so we need that. But that's not enough. Let's say this is a .NET application, and I want to run that .NET application. Let's say .NET Core 3.1. What do I need to run this application? Well, I'll need the .NET Framework Core 3.1. And I may need additional dependencies to run that application. So in other words, to successfully run that application, I need a runtime environment. And this is where we often have a perceived conflict in our industry where we have two concerns. We have a development team, which is responsible for the code over here, and we have an operation team, which is responsible for the runtime environment in production and maybe testing another environment as well. Having two separate teams manage that is, especially two isolated teams, two siloed teams, is not ideal. Why? Inevitably, we'll have to talk about that. But the other thing to recognize as well is a conflict we often encounter, that I've at least often encountered working with numerous clients throughout my career, federal government, financial industry, video game sector, doesn't really matter over here. One conflict that I often encounter, most of you I suspect are familiar with that, is the conflict over here where well, the conflict between development and operation. And where does that conflict stem from? Well, the problem is developers are tasked with changing a solution, right? So developers, one of their, if you want to call it priorities, is to change stuff around, as opposed to operation, where their priority is stability. where they need to meet SLAs, they need to guarantee service level, whatever the case may be over here. So they want stability. And those two concepts seems to be diametrically opposed over here. They lead to conflict. And I know I've encountered that numerous times in my career, working with different clients, even working for different organizations. And a scenario where we need to add something in prod, the prod team's like, no, we can't add this. That would destabilize our environment, leading to conflicting point of view. But the thing to realize over here is that they're not divergent focus. This is not really the focus of the development team. The role of the development team is not changed. The role of the operation team is not stability. Those are means to an end. What are we trying to do? What is development and operation and whatever other peripheral roles that are involved, silos, if you want to think of it this way, are involved over here, where they're both focused, or they should both be focused on the same thing, which is to deliver business value. That's what all IT teams should be focused on. Why do programmers bring changes to their code? To deliver business value, by correcting flaws, by adding new features, by tweaking and refining maybe the UI, tweaking and refining processes, accelerating processes, doesn't matter. We're doing that to ultimately deliver business value. Operation, how do they deliver business value? Well, they do that by offering a runtime environment that is stable, predictable, manageable, all those great things over here. And that is how we're going to deliver business value. One cannot exist without the other. What's the point of having code if there's no environment to run it? I've got this wonderful .NET application, ASP.NET Core 3.1, but we don't run ASP.NET Core on any of our production server. No business value. The opposite is also true. What's the point of having that really nice server running .NET Core 3.1 if there's no code that runs on it? So one is indissociable from the other, all right? And that's the part I'm going to put a lot of emphasis on as we carry along. When we talk about containerizing an application, we are talking about creating a container that doesn't just hold on to code, but the full environment that is necessary to run that code. And this will deliver tremendous value at numerous levels, numerous stages, as we'll talk about very soon. The other thing I'd like to highlight for you guys that I think is extremely valuable, and that, in my opinion, is what made Docker such a winner in the industry. It's not necessarily the only solution that does that today, but it was the first to really make it a commodity. The idea that those containers are portable. I can create, let's say, as a programmer, I can create that container over here on my machine. So write the code, choose the environment, configure the environment to run my application. And once I'm done, what I can do is put it in a container. I'll demonstrate that. I'll show you how that takes place. And now that it's in a container, what I can do is push that container to a repository. A repository that can then be used by, say, my testing team. Ideally, it wouldn't be a separate team, but we'll go with that for now. The testing team, the testing endeavor would be preferable to verify that the code runs correctly. And the beauty over here is when I give them that container, they've got everything that they need to run the application. They don't need to install anything special. They don't need to configure anything. They can just boot it, run it itself, which means now here's another advantage to containerization that I think is very important for us, is that let's say, just for the sake of that discussion over here, that application over here needs Java, the JDK, right? That would mean traditionally I would have to install Java on the host machine or the virtual machine. This one needs .NET. This one also needs, let's say, Java, but a different version. So we need, let's say, JDK 11 over here. Here I need JDK 14, just as an example. That would start to add some complexity if I needed to install this on my host OS. Well, that's yet again another advantage that we're going to see in action. I don't need to install anything on my host system. The only thing I need is containerization, Docker in our case. And then I can run whatever. All right. And again, that's something I do want to demonstrate and highlight how that will deliver value to us. And there's more coming up when it comes to that, but let's keep it in mind. I think that's going to be for us the most important value proposition behind containerization, the idea that now we have the ability to not just package code and push the code to a development machine, what we might call throwing it over the fence traditionally, but now we have the ability to put together the code and its runtime environment together in one package and then share that package. Push it to a repository that can then be used by other segments of my business. Now, to take advantage of containerization, there's a couple of approaches you could take. The least desirable, but it will still provide value in my opinion, would be let's not change anything. Let's just keep on doing development and operation the way we do it, especially if we're doing things in a siloed approach. Well, let's just keep on doing the things the way we do it. The only change we're going to do over here is we're going to start using containers. Sure, you're taking advantage of technology. All right, now I like to think that this will most likely serve you well, but to maximize our use of containerization, let's move away from silo. Let's move away from throwing artifacts over the fence and passing the buck from different silos, dev and test and auth and whatever else out there. And instead, let's talk about integrating those processes together. So what am I getting at with that? I think most of you have probably figured out. I'm going towards the idea of DevOps. What is DevOps? Now, I don't want to turn this into an intro to DevOps, but this will work very nicely with the discussions we are going to have. You do not need to be DevOps to take advantage of containerization. However, if you take a look at pretty much any mature DevOps organization, I think you'll find pretty much all of them will use containerization. Not a coincidence. You don't also need containerization to be DevOps, right? You can do DevOps without using containerization. But containerization is a tool that will enable a lot of DevOps capabilities. So let's take a step back over here and let's talk about what is DevOps. Misconception, a lot of people assume that DevOps is simply let's shatter, let's break apart the silos, get everybody together and say, now you're working as a big team, go ahead and figure it out. It's not a bad start, but I wouldn't say we're DevOps. Another scenario that I see out there is to become DevOps, we're going to get a pipeline. We're going to use Azure DevOps. We're going to use Jenkins. We're going to use TeamCity. We're going to use Travis, whatever. Hey, we've got a pipeline. Cool, we're DevOps. Actually, you're even less DevOps than if you break apart your silos, right? So when it comes to DevOps, what is DevOps about? Well, fundamentally, it should come down to not integrated team. Integrated team will be a means to an end. What we want to have over here is an integrated process. And let me highlight that process, right? A bit of a somewhat mature DevOps-ish process from mostly a technological perspective, and we'll view that process a couple of times as we talk about managing those containers. And also one of the things I want to get into is why should I worry about managing those containers? They sound like they manage themselves, but let's get to that as we carry along. So one of the things I'm going to do over here, let me crack that open. Here's the scenario I'd like to discuss with you guys. So on the left over here, I've got my development team. On the right, I have my production environment. And the goal over here is to get working code from the development team to my production environment. How are we going to achieve that, right? Without resorting back to silos. Well, I'm going to throw some tools name out there, right? For example, I'm going to use as an example Jira over here. Does that mean you have to use Jira? No. You could use whatever system you want to manage bugs and changes and whatever you want to do. But what's important over here is we have a system in place to keep track of the evolution of the system, changes that we need to bring to the system, and those changes could include new feature requests, as well as environmental change, as well as bug fixes, as well as even test changes to your application over here. So moving ahead, when it comes to that, so we have a system over here by which we can keep track of what we need to do. So a request comes down the pipeline. Now, ideally, we're going to do this in an iterative approach, for example, using Scrum. Doesn't really matter. It's not really important for this discussion. What's important over here is a request comes down. Let's say we need to provide a new feature to the application. By the way, I'm seeing a couple of great questions coming up in the question windows. I'm not ignoring you guys. I'll get to those as we carry along. Keep your questions coming. I do appreciate them. But let's say over here, a change request comes down the pipe. So we need to bring a change to the application. How do we normally go through that? Well, of course, the dev team receives that change request. What we're going to do over here is, in an ideal scenario, the team will self-organize. And the team, by the way, I should take a step back. When I'm talking dev team, I'm not just talking programmers, but I'm talking about every skill set necessary to develop and even operate that solution. So this is more of a DevOps team, right? Yes, there will be programmers. There will also be, as necessary, DBAs. There will be testers. There will be folks that are familiar with requirements, architect, technical leads, networking, whatever. Security would be an important one as well. So we have members of the team that are familiar with a wide variety of skill set, a wide variety of domains. So the dev team organizes itself, and one or more members say, hey, I'm going to work on that. So what they do over here is they're going to go to our repository. I'm proposing here Git. I like to think that Git would be a solid de facto to use when it comes to source code management. You can use alternatives if you want to, but the reality is the industry has more or less standardized on Git. If you're not going to use Git as your source code repository, make sure you've got a good rationale to do so. Make sure it's not simply a, well, that's the way we've already done it. As an example of that, very often, well, not very often, not today anyway, some people will say, well, we're a Microsoft shop. We don't use Git, we use TFS. Now, that tells me you don't really know Microsoft, because Microsoft uses Git. They don't even use TFS internally, right? The Windows code base, the Office code base, all those large systems have been moved over to Git. So anyway, we clone or pull the entire source code over here. Now, I did say that this is a member of the dev team, and I am talking about source code. And now you might be thinking, okay, well, obviously that member is a programmer. Not necessarily. Now, I'll come back to that as we carry along. But whoever is working on that request over here is going to grab a full copy of the code on their machine, and they're going to work on that code, do whatever we need to do over here, in this case, to fulfill the request that we received. Once we're done, we tested it, seems to work well on our machine. Let's push it back to the repository, and boom, a pipeline comes into play. Again, having a pipeline doesn't make you DevOps. You can be DevOps without a pipeline, might be a little bit harder. And having a pipeline doesn't mean you are DevOps, but chances are, as we mature through DevOps, we will have a pipeline. So what does the pipeline do? The pipeline, if you're not familiar with that, it would be a piece of code that would automate a workflow, a build, test, and potentially deployment workflow, as we'll explore over here. So as we pull the code from our Git repository, we'll need to restore dependencies. Those dependencies may come from the internet. For those of you who come from Java, things like Maven, Gradle. If you come from .NET, NuGet. If you come from Node, you would use your NPM, Node Package Manager, or whatever programming language you may be using. If you need more control for the sake of security, for the sake of what's the word I'm looking for over here, to be compliant with a regulation in your industry, you could slap on a local repository of those packages like Nexus, Artifactory, or whatever makes sense for your need. Then we're going to do a full rebuild. You might notice over here that there's a little word that I dropped over here. We're certainly going to come back to that one, Docker. But let's put it aside for now. That's going to bring us to our tests. We do our battery of tests, unit tests, integration, system, security, UAT, UI, UX, and all of those should be automated. And of course, we're going to send back a test report to our team over here, letting them know here's the success, here's the result of our test. Now, this would be the end of the continuous integration part of the pipeline. I'm not going to spend too much time on that concept. What we're getting into over here is the continuous deployment part of the pipeline, where we're going to prepare the code package. And because we're talking about containerization over here, I'd say it would be fair to assume that we are going to containerize this application. We'll talk about how as we carry along. We're going to push the package to a repository, something I hinted at previously. And should we be ready to roll it out, we're going to get to a deploy phase over here. And as part of the deploy phase over here, we're going to use automated tool like Kubernetes. I'll talk a little bit about that one later on, to push the code and its environment into production. So I do want to come back to that in more detail as we move ahead, but bear with me for now. So I just wanted to refresh a fairly prototypical DevOps process. All right. So before I move ahead, let me put that aside for now, and let me take a look at some of the questions that we have over here. The first question I get over here is, will you be covering Vagrant in this presentation? It wasn't my plan, but if you have any specific questions, throw them my way. I'll do my best to answer them. Would a disadvantage of containerization be additional licenses? Depends, right? Additional license costs. It depends. Yes or no? Let me come back to that one as we carry along. And then, actually, if I can take a step back, there is a chance that you can save on licenses easier with containerization than with virtualization. Another great question over here: can you run a Mac OS? Can you run Mac OS in a Docker container? Not really. Yes and no, in the sense that Mac is a Unix operating system. So you can certainly, no, let me take a step back. Short answer, no. Mac doesn't support containerization. Windows has its own flavor of Docker, which runs pretty well actually. But quite honestly, if you want to get into containerization, I'm gonna strongly recommend do so via Linux. Right? There's a number of advantages to that. Containerization, Docker wasn't really invented in a vacuum. If you take a look at the technology that makes Docker do its magic, they come from the Linux kernel. And I'm not trying to get into a discussion of operating system, Linux versus Mac versus Windows over here. They're all great operating systems, but they're also three very different operating system. They're architected very differently. Mac and Linux, of course, a little bit closer in their design. They're both Unix-ish. Windows, very different in terms of its design. Chose a very different approach than Unix. Makes it very capable in many ways, but because the architecture is different, Microsoft had to work very hard at providing the necessary capabilities to support containerization in Windows. So realistically speaking, if you can, use Linux. So you want to run containers on your Mac, I strongly recommend use existing solution where you can where typically we use virtualization, things like VirtualBox. There's pre-packaged VirtualBox downloads that you can use over here, DMG files, to install Docker on your machine, but you would do that via virtualization. You would boot a very lightweight Linux distribution that would allow you to run Docker on your Mac, but you would be using that to run Linux application, not Mac application. On Windows, you have the same capabilities that's open for you. You can run lightweight Docker images in VirtualBox, in Hyper-V. But the approach that I like to recommend that you use if you are using Windows 10 is to use WSL, Windows Services for Linux, which I've got running on my machine. So whenever I'm doing Docker development, and some of the demos I'll be doing will take advantage of that, WSL, Windows Services for Linux over here, that's going to bring me into a local Linux Linux runtime over here. I'm running my own Linux kernel, pretty much side by side by my Windows NT kernel over here. This is a Microsoft solution. This is not a third-party thing over here. You go to the Windows Store at Windows 10, look up WSL. You'll see it's right from Microsoft over here. It's an add-on to Windows 10. It allows you to run Linux side by side with Windows. Why did Microsoft offer that? All right. Well, one, the reason is you want to run Docker on Windows 10, best solution. All right. There are alternatives you could consider, but that's the best solution to you. So just some food for thought for you guys. I do appreciate your questions. Please keep them coming. But now let's talk about using containerization, or about using and delivering value via containerization, and furthermore, managing those. Since I'm assuming in the session that we have right now, I've got managers, folks that are in charge of a technical team, development project, maybe even operation over here. How do I manage this? And what do I need to know as a manager to really take advantage of containerization? Well, to get us started over here, let's begin from the beginning. All right, I'm going to rewind all this over here, and let's talk about development. How can containerization help me in development? Well, if you remember the very blurb for that presentation, I'll see if I have it open somewhere here. I thought I had it open a moment ago, maybe not. But one of the things over here that I want to remind you of is I want to explore the situation where most people have probably encountered that if you work in the world of software development, you develop a piece of code, works great on my machine, doesn't work on somebody else's machine. Why does that happen? I think we're all cognizant of that. It happens because there's difference in configuration between my machine and somebody else's machine. It could be, for example, different version of the JDK or the .NET framework. It could be files are in the different location. It could be an environment variable that is not set correctly. It could even be a slightly different version of Windows or Linux that I'm using over here. Doesn't matter. What matters over here is it worked fine on my machine. doesn't work on somebody else's machine. So the first value proposition I want to highlight over here is what we've talked about previously, the idea that a container contains both the runtime code for your application as well as the environment that I need to run that code. I don't need to install any of that on my machine. So it makes it much easier for me, a programmer, let's say, to write an application, package everything in a self-contained container, push it to a repository, and then my testing team, my operation team, even other developer, doesn't matter what their role are, can then pull that container to their machine and run it locally. Not a problem, right? So that's the first value proposition for us. And I think it's an important value proposition for us when it comes to containerization, ensuring that the application flows with its runtime environment. Avoid the situation where, for whatever reason, works fine on one machine, doesn't work on another machine. But that's not the only value proposition I'd like to highlight for you when it comes to containerization. Another scenario to consider when it comes to containerization is, okay, it's one thing, let's go back to that scenario over here, and I know as a developer myself, this is something I've encountered numerous times, right? Whether I'm working with a team, I'm working with an open source project, doesn't really matter over here. I want to check out some code, so I'm going to clone some code locally. There it goes. I've got the code locally on my machine. I go to work on it. I click the run button in my development environment. Compile, compile, compile. Whole bunch of red text. It doesn't compile. Why not? All right. I may be, well, obviously I am missing something. I may be missing the development environment, the Java developer kit, the .NET framework development tool. I may be using the wrong version of a tool. For example, Node 8 when I should be using Node 12 instead. So because of that, this is going to cause the build to fail in different environments. Another reality as well to be aware of is that if your team is working on different projects, right? I've got some project, let me use Java as an example. I've got some project that uses Java 8. I've got other project that use Java 11. I've got other project that use Java 14. That's going to make developing that application a little bit more challenging. Let's say over here, I'm working on my Java 8 project and I write the code and I compile it. Oops, but I accidentally compile it with my Java 14 SDK. Well, what does that mean? Well, okay, I've got something that works right on my machine. Push it over to my repository. What's going to happen? Well, when somebody downloads the code and goes to run it, if I'm trying to run it with Java 8, it ain't going to work, right? So how can containerization help me with that? I'm not going to get into the technical aspect of that, but when it comes to containerization, the solution to that is to have what we call a two-stage build, where instead of building the code on your machine, then copying it to a container, what I'm going to do over here is I'm going to build the code in a container. As an example, if you want to think of it this way, let me go back to the whiteboard over here. What I could do over here is, as I build the code over here, instead of, again, using my local tool, which could vary from machine to machine, what I'm going to do over here is I'm going to bring down a container, let's say a container that already has the Java developer kit installed. We'll talk about those as we carry along. So I'm going to use that to build my code. So I'm going to copy my raw code to the container, do the build in the container, and as part of an automated process, all right, so I'm not going to be doing that manually. I'm just going to set up the rules to do that. But as part of an automated process, what I can do next is bring down another container. And let's say for the sake of security, I'm just going to bring down the JRE, the Java Runtime Environment. So what I need to run a Java application, not write a Java application. So here I've got a binary artifact, let's say a jar file that was created. That would be a compiled Java code. What I'm going to do is I'll copy it to that container, copy it to that container that already has the JRE, grab that container, copy it, push it to my repository. And again, I want to come back to that repository over here. So push the container to that repository. So what's the advantage that I have over here? Well, the important part over here is predictable builds. Not just predictable runtime environment, but predictable build. I want to rebuild that application. I want to allow different members of the team to rebuild the same application. I want to ensure that when we rebuilt it in our pipeline that we were talking about previously, we're always going to use the same environment. We're always going to use a predictable environment in which we're going to do our builds. So that's the second advantage I want to bring to your attention when it comes to using containerization in development. The first one, again, is the ability to develop the application once and then package it in its runtime environment and push it through its entire life cycle. Second advantage is I can make the builds for the application. I think we all recognize in one form or another as a manager that building an application is not getting simpler. Just getting more complicated. Yes, we have much better tools than we've ever had when it comes to assisting us when it comes to doing a build, but a build is a very complex endeavor. Now I can make it more predictable thanks to containerization. Now, one of the things that I've been talking about is containers that include, for example, a different version of the JDK, containers that might contain .NET, that might contain Node, that might contain whatever. Where do I get those containers from? Am I expected to build them myself? The web would build a virtual machine. You could. It's a lot of work. I don't recommend you do that yourself. Instead, what I like to recommend that we do over here is use hub.docker.com. Some of you may be familiar with that site. I'll paste this in the chat window if there's any interest. Boom, there we go. Hub.docker.com. This is a free service, so there are commercial offering for it. And the idea over here is hub.docker.com, which is hosted by the Docker company, the same company that develops Docker over here. Docker is open source, by the way. The Docker software is open source, no licensing costs behind it, but the Docker company does host Docker Hub. And from here, I can find numerous containers for base containers for my application. So for example, I've been talking about Java, so I would need the JDK. And I've got choices over here, the Oracle JDK, the Java SE JDK, Java SE JDK, and Maven, if you're familiar with that. I'll go with the Java SDK over here. Well, that's interesting. Provided by Microsoft, because that's what they use in Azure. There's other ones I could look at. I could look at OpenJDK. That's usually the one that I personally use. This one is a Docker official image. So it means that this image was actually created by the Docker company with their experts when it comes to containerization, when it comes to setting up those containers over here. So they're maintained, they're designed with best practices. They're also open source. You can actually go online and see how the container is built over here. But if I need to build or run Java application, there it is for me. If you're more of a .NET shop yourself, not a problem. I've got a number of .NET container. I'll go with .NET Core. Who offers that? Again, none other than Microsoft. Who knows .NET better than Microsoft? There it is. So they offer us .NET Core and traditional .NET containers over here. If you're working with Node.js, here it is. That's again a Docker official image. And there's plenty of other images that we can use, base images for our containers. So instead of building a container from the ground up, as you would with as you would with a virtual machine. Here I've got pre-built containers for me. Is there any cost behind them? Let me go back to a question that was asked earlier. What are the licensing costs to use Docker? Well, first of all, it's open source, no cost. For example, WSL, but I haven't really fully demonstrated just yet, but WSL, no cost. All right, you go to the Windows Store. I should say the Microsoft Store. I did say Microsoft Store, so it might sound kind of scary, but there's no cost behind it. All right, it's a free solution Microsoft distributed through their store, like so many add-ons to Windows 10. When it comes to hub.docker.com, no cost behind using it either. You'll notice there's a scary button over here that says pricing. Ooh, what do I have to pay for? Well, pricing is if you want to use Docker, hub.docker.com, to host private repository. All right, every image that we see over here is public. Anybody can use them for free. But if I want to host my own repository privately, then there's a cost behind it. And there's alternative. We'll talk about that very soon. But then if you go over here, you'll find some surprising application. If I go over here and look for their goal, let's say we're an Oracle RDBMS shop. Oracle RDBMS. Actually, I can use WebLogic. That's another one. I was hoping to find just Oracle RDBMS, but Oracle WebLogic Server. Now, some of you might say, wait a minute, I thought WebLogic was a commercial software. We needed to pay licenses for that. How come I can run it through Docker over here? What's the deal? Well, be aware that some containers that are provided for you, especially by third parties like Oracle over here, may have license costs behind using those. How do you pay for those licenses? You don't pay to it through Docker. You pay for those licenses via the vendor itself. So in our case, Oracle. How do you acquire license? Again, it's going to depend on your vendor. How do you apply the license to your container? That's going to be specific to the vendor again, but they're going to give you step-by-step instruction to enabling the license on the container. Though many of them, like in the case of Oracle WebLogic, in this case, there is a developer tier, which includes blah, 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 blah. I was hoping to, well, don't necessarily want to get into terms of service, go away. Let's go back over here. But the developer tier would be free. And there is also a runtime tier that would require you to have a license from Oracle. But that actually brings me to yet again another development advantage to containerization. Right? I said there's three important advantages. Again, first one is making sure that the code that we write, we don't just package the code, but a full runtime environment necessary to run that code. The second advantage, again, was predictable build, repeatable build. I don't need to install anything special on my machine beyond Docker to run those builds. Third advantage is it allows me to run resources locally on my machine. I'm going to use myself as an example. If I'm doing work for one client, that client may expect me to use, say, a Kafka as part of their solution. The solution will make use of Apache Kafka, so I need to have an Apache Kafka server running plus Zookeeper plus whatever I need to run Kafka. Then another project may require me to use MongoDB. All right, and then I go to another project, and this one needs SQL Server. And then I go yet again to another project, and this one requires Spark plus Kafka plus yet again something else. Ooh, that's a lot of technologies I need to install locally on my machine. Again, the traditional way I would do that, I will go to the vendor site, download the application, install it, configure it, bring it up, and once I'm done with it, because I don't want to have all those servers running on my development machine, I also need to bring them down, maybe uninstall them. And we know what happens when we uninstall something, right? It's always going to leave crap on your machine. So one of the things that I do today is I no longer install software. Most software that I install, I no longer install it directly via an MSI or via a package. If I just need to run a transient tool, like some that I've mentioned previously, guess what I'm going to use? Containers. All right, a couple of examples I'd like to show you over here. If I need to run, let's say Kafka, right, message streaming solution, very, very popular today. When it comes to Kafka, thank you. There's Kafka Manager. I think that would be adequate for me over here, but no, that's just for Kafka Manager. But there you go. I could use that to bring up a Kafka instance. Have my code now send and receive messages from Kafka. I haven't installed anything on my machine. All I need to do is run it. You'll notice over here, they do give you the command to run it, and they also tell you how to configure it to work correctly over here. Set mvar $zk host to zookeeper. What the heck is that about? Don't worry about it too much. But I'm just going to use that as an example over here. But I'll come back and demystify what the heck they're talking about over here. And I'll even demonstrate that. Not necessarily with Kafka though. I need to run, let's say I need to run MongoDB, the most popular NoSQL type of database out there. There we go. There's Mongo. It's an official Docker image. To run it, I can just do a Docker run Mongo. Boom, it's up and running. Actually, let me demonstrate that. I'm not going to use it over here. Don't worry too much about what I'm going to run. I don't want to get too technical. Not that it would be, but I'm going to say go ahead and run a MongoDB database on my machine. Bring it up. Give it a second or two. And boom, it's starting up over here, but it is running in a container. I'm not installing anything on my machine. Now, a couple of files were indeed downloaded, copied to my machine. I can remove them easily later on, but it's not adding keys to my registry. It's not sprinkling my system with a whole bunch of executables that are going to run at startup and license manager and whatever else. Fully isolated in its own container. So there it is, it's up and running. So once I configure it correctly, it's not actually fully configured just yet, but once I configure it, then I can start writing code, issue requests to my Kafka server, get responses, boom, I'm up and running. One last example, I'll hit Control-C to stop it. There's other ways by which I could stop it. Here's practical example. Earlier this year, I needed to develop content that required SQL Server, Microsoft SQL Server. Of course, I could have downloaded and installed SQL Server on my local machine. That's a lot of work, takes up a lot of resources, all right? And I'm also running Windows 10, not Windows Server. Windows Server would be preferable for that, not a problem. In here, we have Microsoft SQL Server for Linux. By the way, if you did not know that already, Microsoft a couple of years ago ported SQL Server to Linux. You can now run it on Linux the same as running it on Windows. So what I did over here is I've used that official image by Microsoft, so not a third party. This is not hack software or illegal software that I'm using over here. Actually, they moved, oh no, they just moved their code over here, but there's, that's what I used over here to run SQL Server on my machine. And I can even show that to you. I can show you my images over here, and you'll notice that I do have SQL Server as an image that I ran previously. Same thing with MongoDB and other applications. I'm not going to go through the whole list over here, but I'll highlight that as we carry along. So I'm able to run SQL Server directly on my machine without installing anything. Once I'm done with it, stop the container, not using up any RAM, not using up any CPU, no pollution in my registry, no pollution on my disk. Of course, some files are located over here. You can see that there are some files. It's actually 1.5 gig worth of data that is used on my system. It's a big system. SQL Server is big, but I can always delete it by, actually, let me do that right now, by doing a Docker RMI, remove this image. I'll grab the image ID. And oops, let's just force the deletion. And boom, it's gone. Let's take a look at the images. It's no longer there. I freed up 1.5 gig of disk space without any leftover. All right, I love that. I love the fact that now I can run a variety of tools without polluting my system. So at this point, I'm hoping that we start to recognize from a programming development perspective, I don't want to just leave it as programming, but from a development perspective, we're already seeing some value over here. So as a manager, some of the things I like to recommend that we consider doing over here is, as best as possible, educate your team on Docker. Now, I'm gonna put in a bit of a plug over here. Hope you can forgive me, but hey, at WebAge, we've got great courses to help anybody get started with Docker and peripheral technology. But following that, let's get them up and running with Docker using tools like WSL, using Linux images, running on Linux directly, whatever we need to do containerization. There was a question over here, what is the WSL equivalent for macOS? Microsoft hasn't released an equivalent. You can run Docker through virtualization on the Mac, and actually there's a number of great resources for that. I'll be honest with you, I haven't touched the Mac environment in a couple of years, so I'm a little bit rusty when it comes to that, but Docker Mac OS is certainly a thing. I mean, if I were to crack open my old PowerBook over here, I would be able to run Docker locally, but there go installing Docker desktop on the Mac. Here are different solutions available for you. For those of you who are interested, there it is in the chat window. But going back to the original question, what is the Docker equivalent for Mac? What is the WSL, Windows Services for Linux on Mac? There's no equivalent. Microsoft hasn't released that. The closest equivalent, actually, you've got something even better in a way, Bash. Crack open your terminal, click on Spotlight, type in terminal, you've got your Bash shell, the exact same thing that I have right over here. It's native to your Mac. The only thing is, to run Docker, I would recommend review the site that I've presented for you and let me know if that works for you. That should allow you over here to run Docker on your Mac. So lots of good questions. I do appreciate your questions. Keep them coming. Now, before we move ahead, the next thing I'd like to discuss over here is using Docker in testing. All right, where does that come into play for us? Using it in our pipeline. And of course, let's talk about using it and managing it in prod. And that's going to be an important discussion for us. Before we do so, I'm looking at the time. It's already 11:15 Eastern time. I'm going to suggest let's have a quick break, give you guys a chance to walk around, refresh yourselves. Let's resume 11:30. Sounds good for you guys? I'll take that as a yes. And again, let's resume at 11:30 Eastern time. If you have any questions between now and then, leave them in the question window, leave them in the chat window. I'll make sure to get to them when we resume. Have a good break. It's just about 11:30. I'm assuming you guys had a chance to enjoy a bit of a break, walk around, refresh yourselves. Before we forge on, can I confirm you guys hear me okay? If you could let me know via the chat, give me a thumbs up. That would be appreciated. All right. Perfect. Thank you very much for confirming. So moving ahead, this morning we were talking about, in a nutshell, what is containerization? Where does it come from? How does it fit in? Superficially in a DevOps process, we'll come back to that very soon. And finally, the three of the value proposition of using containerization during development: predictable code to roll out by rolling out not just the executable, but the very environment needed to run the executable. And by extension, we also talked about the advantage of having complete isolation in which my application runs. Following that, we also talked about the advantage of creating reproducible builds, where you do a build or you do your build in a container so that anybody down the line who acquires the code, who needs to rebuild it for whatever reason, not a problem. They don't need to install anything special on their machine, and they can do that build predictably, even byte for byte in many cases. And finally, the last advantage is the ability for the development team and operation to run a variety of tools, especially ad hoc tool that may be necessary to develop, operate that application without having to install the tool locally on our machine. Now, of course, I'm not saying you should not install tools locally on your machine. There are some things that will not work naturally in containers, things like desktop application. But when it comes to server-side tool, like databases, messaging system, supporting system, monitoring, whatever the case might be, Docker containerization is a natural contender for that. You guys have been asking a lot of good questions. I'm hoping you'll carry that along as we move ahead. What I would like to do over here is move ahead in our discussion where we are hitting the pipeline over here. And I do want to refine a little bit the suggestions that I've put in place when it comes to managing containerized application. Let's move that again with a bit more of a DevOps tangent. If I can go back to that pipeline over here after restore dependency, we do a full rebuild. And notice over here in the pipeline is where I'm also rebuilding the container. So it does imply that a container will be built into two separate places. The first place will be on the developer's machine over here. And again, by developer, as we'll elaborate later on, I'm not just talking programmers. But as a developer over here, I'm going to use Docker to create predictable, executable, predictable build, bring up the environment that I need to develop the application, bring it down when I'm done. And I should mention another technology that I'm not going to get into, but I'll mention it in passing, Docker Compose. All right, that's something that your development team may want to look at if you need to bring up a handful of services to operate your application in development or in testing. There's a wonderful official tool for that called Docker Compose. I'm not going to get into this one, but I'll mention it over here, something you may want to pass again to your development team, to your Docker users over here, getting into the use of Docker Compose to bring up the development and testing environment, operate in it. Once you're done, one command, boom, you bring it right back down. No more resources used on the host machine. All right, but that's going to bring us over here to our test. Now, as we are building that container over here, there's a couple of variants we could look at, right? But we've built that container over here. That container that we would have built, let's use it to run our battery of tests that we have over here. And once we're done that battery of tests, that container over here, as we get into continuous deployment, we're going to grab that same container, so the container that we built over here that we ran through that battery of tests. We're then going to grab that same container and push it to a registry. Doesn't have to be the same registry that we use to restore our dependency, our Maven registry, our NuGet registry, whatever registry we may have out there, but let's push the container to a registry. And one, the important reason why I want to do that over here is as we move ahead, as we get into production over here, as I get into deployment, I can ensure that the container that I've put over here in my registry is the exact same one we're going to use in production. Why do I want to do it this way? Well, let's go back to one of the premise of this seminar over here. I want to avoid the situation where, for whatever reason, works on my machine, doesn't work on another machine. So we're going to ensure over here that from development to testing to staging to prod to whatever else, we're going to stick to one container. In this case, you could argue two, because we're going to build one in test to do our development, our iterative development cycle. What we push back to our Git repository is source code, not binary code. So the container doesn't go in there, but Docker files will go in there. I'll highlight that for you guys. The official build we're going to use, let's put it in our build over here, in our pipeline, in the testing phase. Let's continue using that. So a couple of variants you could consider using. You could do the build and then push it to Nexus, and then start the test from that container that you push to Nexus. Advantage, you've got a copy of every build that you've done. Potential disadvantage, most of those builds are probably going to be, I don't want to say garbage, but may not work. So I may be holding on to containers that are non-functional. Another approach that you could consider doing is the one that I proposed earlier. Do the container over here, then use the same one to do your battery of tests. And once those tests are successful, then push it to the Nexus repository as part of your CI pipeline. But that's really what we're doing in the next phase anyway, prepare package. So there's variants, whatever makes sense for your development effort. And of course, as the complexity of an application increases, then the complexity of the pipeline is probably going to increase as well. We need to tweak and refine that as necessary. Okay. Another advantage when it comes to Docker in testing environment. One premise of testing, right, especially in a DevOps environment, is we want to make sure that the tests are highly reproducible and ideally fully automated. Let's move away from manual testing. Let's automate as much as possible. Let's automate everything that we can. That's a DevOps process. That's a DevOps principle we're talking about over here. So using technologies like Docker Compose that I hinted at previously would allow me to, when I'm running that pipeline over here, when we hit the test phase, let's say I need my MongoDB database, I need my Spark cluster, I need my Kafka streaming service, I need whatever else. Using Docker Compose or similar approach, could just be a script as well that I developed myself, but this would allow me to bring up my resources to run that test, execute the code, do the battery of tests over here. Once we're done with that test, bring down that battery of tests. Okay, you might say, cool, it would be kind of the same as booting up a VM when we need to do our test. Once we're done, we shut down the VM. But the advantage I want to highlight over here, and this is natural in Docker, the idea that I'm going to bring up my container, run the code, all right, so bring up all my peripheral solution, let's say my MongoDB database, start reading and writing records, so modifying the state of the database, but make it so that when I bring it back down, I wipe out whatever changes I've done to MongoDB. So it means that the next time we go through the test over here, we bring the environment back up, and the environment is going to be clean, vanilla. Any changes that were done previously, poof, they're gone. And that's important over here. I want to ensure that every time I bring up my test environment, that it is clean. It's a clean slate over here. And instead of trying to use script to clean it up and reinitialize it, let's just set up the containers so that they're ready to go, bring up the environment. It will be much faster than booting a VM, because at this point you're just running applications, right? No need to boot up an operating system or operating systems if there's more than one VM involved. So faster to bring up the environment, less resource used, and finally, clean slate every time you run it. Now I'm going to get a little bit technical over here to explore how we achieve that clean slate, understand some of Docker's magic as well, and show you what I meant by better resource usage when it comes to running containers as opposed to running virtual machines. Let's go back to the whiteboard. When we're talking about VMs, and there goes one of those discussion over here. I was talking about the situation. What if I have two different Java applications? They both require the JDK. Let's say in this discussion over here, they both require JDK 8. Cool. I need to install it twice. Or again, some of the clever one might say, well, JF, just install it on one base image, right? Then duplicate that base image. Yeah, sure. That's okay as well. But there's no resource sharing, which at first sounds like the value proposition of virtualization. But the value proposition over here is not resource sharing, it's a resource isolation. And there's a difference between the two over here. I can achieve resource isolation with virtualization or containerization. But containerization can safely share resources that we cannot do with virtualization. What do I mean by that? Well, before you get scared and start thinking, ooh, is resource sharing, am I breaking apart isolation that we have with virtualization? Well, realistically, no, in the sense that, as I'll show you over here, what we're going to talk about is already built into your operating system. When you launch an application, whether it's containerized or not, that's the way your operating system works. Whether it's Windows, Linux, Mac, doesn't matter. So I'm not going to get too technical over here, but I do want to highlight some characteristics over here of running our application in containers. Let's zoom in over here a little bit, and actually no, let's keep it neat. So I've got my host, and let's say over here I've got two containers over here. Each have their application code. And we'll say that both of them run Java. All right, they both need Java. It could be .NET, it could be Node, it could be Python, it could be whatever you want, not important. What's important over here is they both need, let's say, JDK 11. Doesn't matter. In a VM, again, you install it twice, you run it twice, etc. In a VM as well, most of you may be aware of that, but in a virtual machine, I can create, I can save a state, I can restore a virtual machine to a given state. These are capabilities that I have, and I want to emphasize how that capability is also available for a virtual machine, but we need to change our mentality a little bit. And that's going to segue a little bit also into using containers in production. For now, I want to focus a little bit on testing, but also you'll see that we want to use that same mentality in production. So how are containers physically structured? They're not one big file. So it's not a giant zip file that we push back and forth. All right, if I were to run a new container, let's say over here, I'm going to go back to do my Docker hub. I think there we go over here. And let me pick up a new tool. Let's say I want to use Apache Spark. All right, maybe one of those. There you go, by Microsoft as well. Machine learning over here for Spark. I want to run that container. So I'll just grab the name of the container over here, copy that. And I want to run it locally. So here's what I want to show you. First of all, if I take a look at Docker images, plural, you'll notice in here, I don't have the Spark image. I have a lot of images, but not the Spark one. No problem. Let me run it. Docker run, paste that in here. And actually, I'll add IT. I'll explain what this is about. It's not terribly important for now. Notice the message, unable to find the image locally. So what's happening over here right now is it's actually downloading the image to my machine. But you'll notice it actually downloaded 8 files. All right, downloading over here, it downloaded 8 files. So pull, download, complete over here. I'll give it a moment to finish. Shouldn't take too long. This one is kind of big over here. So 8 files. How come I have 8 different files? There could be more, there could be less. Those are fundamentally disk images, but not in the sense that you're accustomed to, not like a virtual machine. It is not an actual disk with sectors and cylinders and whatever else we may have with our disk. With blocks, it's not a block device. If you know the distinction over here, think of it more as a zip file, right? Fundamentally, that's what it is. So it's almost there. It's taking a little bit longer. But after this is done, you'll notice that it will extract those images, and then we're going to run the container. All right, there may be some configuration I'll need to do. I'll find out very soon, but I'll leave that as is. Let me go back to the whiteboard so we can explore what's happening. Why is it that running that container image required a couple of images to be downloaded? Well, the way that Docker images operate is that they're working with layered disk images. I'm going to throw a bit of a technical Unix term at you, Linux term really, at you, something called Union FS. Now, if you're a bit of a Linux guru yourself, you may be familiar with Union FS. If not, don't worry about it. So what I'm about to discuss over here is one of those things that I hinted at previously that is built in to Linux. It was created before Docker was even a thought in somebody's mind. And this is something that the Docker engineer, I forget his name, the original author of Docker, used. Did not reinvent the wheel. It's already there in Linux. Let's go ahead and use it. So what does Union FS allow us to do? Well, let's say over here, I want to run my application in an application that requires the JDK. And for the JDK to run, I need an operating system, Windows, Linux, Mac, whatever operating system is supported. So the first thing that I'll need is an OS. Now you might say, well, you've already got your host operating system down below. I could install Windows, I could install Linux, doesn't really matter, and install the JDK on top of that. But that would not work. We're talking about containerization. As we established previously, once I containerize that application, I'll containerize both application over here. They run in isolation. They don't even see the host operating system. They don't see the files on the host operating system. So what I need to do over here is I need to give it an operating system image. Isn't that the same as virtualization? No, because I'm not going to boot an operating system. What I'm going to do, let's say I'm working on that application over here. What I'm going to do over here is I'll give it a disk image that will provide all the files that are expected for that operating system. Let's say over here, I'm going to use a commonly used one over here, Buster, which is a Debian version of Linux. Don't worry about that too much. This is just an example. So I'm going to use Buster over here. What does that mean over here? Well, it means that all the files and directories that you would expect to find in a Buster operating system will be there. All right. But the difference is I can't boot it. It's not a virtual machine, right? It's just the files that would have in here. Think of it this way: it would be the same as copying all the Windows files, the Microsoft Windows files, the Windows directory, System 32, and whatever other directories that you have in here, all the executable, all the DLLs that you might need over here, without the NT core. So you would not be able to boot Windows, but you would be able to run those applications. That's fundamentally what I'm doing over here. So aside from this space, at this point, I have used 0 system resources. No RAM is being used, no CPU is being used, just some disk space. And actually very efficient disk space. I'll talk about why as we carry along. Now, I need to install the JDK. I need the JDK, and I've shown you that it's already available for me in Docker Hub. So I'm not going to install it myself. I don't recommend you get into the habit. So as a manager, best practice, please don't ask your development team to build images from the ground up, right? Sometimes I hear paltry excuses like, well, we want to control it, want to make sure it's secure, want to make sure it's fast. Yeah, of course, I respect that, but you're not Docker expert. You don't have the level of expertise that hub.docker has, or Microsoft, or Oracle, or IBM, or whoever else out there who are providing their products through containers, who have security built in, configured for you. Not only are you asking your development team to do more work, because they're manually setting up something they're not as familiar with as those organizations, you are increasing the chances of making mistake, and thus creating a slower, less secure solution that we have out there. And finally, I'm hoping I'm preaching to the choir when I say that most of you, I'm not sure which organization you're with, public, private, that sort of thing. I am willing to bet that if you're in this seminar today, most likely it's because your company is not in the business of creating Docker containers. It's not what we do. We want to take advantage of containerization to deliver business value, further our mission vision that we have as an organization. But I'm willing to bet nowhere in your mission vision for your organization do you have any statement that talk about Docker itself. So it's not what we do. So let's use an image that's already created for us out there, and I'm going to use OpenJDK. Now, here's the deal. I'm not going to download the Buster and then add OpenJDK on top of that. What I'm going to do over here is I'll go directly to Docker Hub, and in here, let me crack open OpenJDK. We've seen this one already. And there's my Docker official image. Docker images have a name like OpenJDK. There it is. I can see the name right over here. But if I move down, they also have tags, all right, where there's multiple versions of that image. And if I take a look at this over here, there's a tag, JDK 16, running on Windows Server Core. So you would need to run that on Windows Server Core, and long-term support 2016. That's an example of a tag over here. I've got another one over here. And there you go. There's one over here called Slim Buster. 16 again would be the version of Java. Slim, this is a slimmed down version of the underlying operating system, and Buster would be the same Debian Buster that I hinted at right over here. There's one over here called Slim, which gives us just enough of the operating system file so that the JDK can run. But any other interaction with operating system file will most likely fail because they haven't been included. And there's another one. There you go. Here's an image that would contain the files for Oracle Linux 8. Now, I do want to emphasize, this does not mean you need Oracle Linux 8 to run that image. What it means over here is you can run it on any Linux machine. And when the image starts up, when you run your application and it looks around and it queries the system, it's going to say, hey, you're running Oracle Linux 8. For all intended purposes, that's what it's going to see. But again, we're not booting a separate operating system. So what's happening over here is when, let's say my OpenJDK image has been built for me, If I use the Buster variant, what the Docker team did over here is they did not create an image with the Buster stuff and then install OpenJDK on top of that. What they have now is two images. And the process to do that actually pretty straightforward. The first one is they've used the existing Buster image. Again, Buster is just the name of a Linux image over here. Hoping I can find it. That's not it. Just give me the Busters. Boom. Should be in here somewhere, but it's not an image that we would use generally directly. Oops, nope. But I'll leave it as that. What I want to show you over here is when we build, when the OpenJDK image was built for us, it was built on top of that image. What does that mean? Well, let's go to building our own image. I want to package this application. So I wrote some Java code, I compiled it, I've got a jar file, I want to run it in that container. Well, what I'm going to do over here is I'll grab my code and copy it to that image. But this will not modify the OpenJDK image. It's not going to modify the Buster image. Instead, another layer will be built on top of that, where I'm going to put my code, my jar file, if you'd like, in here, and whatever else I want to put, my configuration file, additional utilities, whatever else I might need over here. And in here, we're going to see different commands. For example, in the OpenJDK, I'm going to have my Java command, so I can run Java code. In here, I may have, for example, my bash shell, so I can run command. And in here, I've got my code itself for the application. Why am I highlighting those? Well, let's talk about running it. So now I've created an image, which could be composed of 3 layers. There could be 1, there could be 100, makes no difference. Those layers are read-only. When a layer gets created, fundamentally, you can't modify it. Yeah, if you wanted to, you could dig under the hood and start making modification, but it's not the right mentality. They're read-only. All right. So when it comes to installing the JDK on top of Buster, we don't modify the Buster image. We create a new layer on top of it. And when I add code to that Buster image, to that OpenJDK image, again, I'm not modifying the underlying layer. I'm creating a new layer. And here's really the important point I want to get at for you guys. When I run my application, right, a new layer automatically gets created. We'll call this the working layer. So this is created when I run that image, when I run that container. So what does that mean? Well, let's say when I run my application, I'll show that to you in action in a moment, but when I run that application over here, the first thing that I need to do is I need to invoke the Java command. All right, the system, the operating system needs to run the Java command to fire it up. And the way it's going to do that is first going to take a look in the top layer, the working layer. Do I have this Java command, /user bin Java, wherever it might be? No, it's blank. There's nothing in there. Okay, so let's go down to the next layer. Let's go down to this layer over here, the application code. Do we have Java in here? No. So let's go down another layer. Do we have Java here? Yes. So that's the file we're going to use over here. So we load that file, we execute it. Now, as we run it, the Java program will need to find my code so it can start running it. So we're going to look in the working layer. Is it there? No. We go down a layer before. Is it there? Ah, yes, there it is. So we're going to load the code over here and start running it. Now, just for the sake of that discussion, let's say over here I also have a config file. I'm just going to add that over here. And the code needs its configuration file. So of course, we're going to start from the working layer. Is it there? No. We go down to the next layer. Do I have my config file? Ah, there it is. So we load this. Now, for those of you who are concerned about performance, this is fast. All right, it's not going to hurt your performance for your application, whether you use Union FS or not. performance will be quite comparable, right? In terms of resource usage, this is not even Docker doing that for us. This is done at the kernel level, at the operating system level. So Docker just mounts those, what we call mount those layers at the operating system level, so that when we run that application, that stack of layer is already there. So again, it's not even Docker that takes care of that for us. But let's say over here, we read our configuration file, and as part of normal operation for this application, we modify the configuration file. So I want to write something to disk. It doesn't have to be a configuration file. It could be anything. So what's going to happen over here is the rules are going to be a little bit different. When I go to write that configuration file, Docker will first take a look in my working image. Do I have that configuration file in there? I'm about to write to it. Does that file exist there? If no, then the file gets recreated over here. The modification that I bring are brought to the working layer. The underlying configuration file will no longer be used because it's been modified at that point. The modified version will remain in the working layer. So the original image is never touched, all right, never changed. And let's start with that mentality. That's going to be the important mentality for us, where with a container image, once we create that image, we lock it. No more changes to it. If we run it, we're not going to modify the original disk. So any files that I modify, we're going to modify it in a separate image. And here's the ideal I want to strive for. You'll see the point of that presentation over here is that once we finish the execution, we shut down this application. Let's say we're doing this in dev, in test, in prod, it doesn't matter. The ideal we want to strive for is that working image, poof, gets reclaimed. Let's destroy it. Now, this doesn't happen automatically, right? In the sense that if for, let's say for troubleshooting purposes, you want to take a look at the working image, some log files might have been written to that logging image, you want to take a look at it, technically still there. You can go into it, explore it, navigate through it, not a problem. All right, but the idea over here is when I rerun the application, by default, a new working layer gets created for us. And then we start using that new version, vanilla working layer at this point. We don't use the original, the one that was modified previously. And I think that's an important point over here. It may require some getting used to, but we should treat our containers as being stateless, right? When we run it, if they fail or if we shut them down normally, then when we bring them up, we always want to bring them back up with a clean slate. So this is going to help us with a number of scenarios. Testing, as we're talking about previously, this ensures that no matter how many times I run this application, I run this container, it's always going to start with a clean slate. So success or failure of a previous test, changes that were done by the environment to a previous test, will not affect this test that we're running right now. And the same applies to production. And we'll talk about that very soon. But when it comes to running my application in production, if a container fails, if one of the application fails or is simply shut down, restarted, what should I do how should I restart it? Well, the ideal is let's restart it in a clean slate, especially if it failed because of something wonky that might have happened. For example, it wrote information to disk, ran out of disk space. Whoop, if we try to restart it, chances are it'll fail again. If we constrain the disk space for that container, it means there should still be some free space on our disk. Or if we wipe out the working image, it implies that restarting it in a clean slate would mean that we can bring it back up and not fail because of the reason that caused it to fail previously. Of course, if I don't fix the problem that might have caused it to fail in the first place, it may fail in the future later. But the idea over here is whatever environment caused that caused it to fail in the first place ideally would not be present when I rerun that container. So I think that's an important characteristic that we have over here. And as a general best practice, both from a DevOps perspective and from a microservice development perspective, if you don't already do that, as you architect your application, I'm going to recommend strongly encourage stateless architecture. What do I mean by stateless? Well, the idea over here is that the application does not maintain state, does not keep track of who you are. A classic example is the shopping cart example over here, where a user navigates a website over here. They see an item that they like, they put it in their shopping cart. Of course, we need to keep track of which user added what to their shopping cart, which user is where in the checkout process, what orders have been placed. But the code itself that we're going to write, let's write it stateless. What does that mean? Well, what I'm saying over here is ideally, for those of you who are familiar with sessions in your code, let's not use those. All right, you can if you really want to, and it's okay for very transient purposes, but ideally any state that you need to store short-term, long-term, put that in the database. And if we could start moving to production use of Docker, here's a question that I get asked very often. Can I run or can I use Docker to host my database? Well, on this point, I'm hoping that the answer is kind of becoming a bit of a yes based on what we've seen, with an important caveat. Yes, in the sense that I've shown you, hey, I can run SQL Server in a container. I can run Oracle RDBMS in a container. I can run MongoDB in a container. Name your favorite database. There's a good chance it's there. I mean, if I go back to hub.docker.com, go back at the top over here, and it says, search for great content, example, MySQL. All right, so as a default example over here, you want to run a MySQL server, there's a Docker container for that. You want to use Postgres, there's a Docker container for that. You want to run DB2, there's a Docker container for that by IBM, none other, right? So you've got Docker container for pretty much any database, relational or otherwise, out there. Now, what some of you might be thinking, okay, it's cool, I can run a database in a container, and obviously my data files will exist in that working directory, that working layer over here. But what happens if my database server shuts down for whatever reason? Fault or upgrade or whatever. As I suggested earlier, the ideal over here is we wipe out the working layer, which would imply we wiped out our database. And I don't think that would work very well for production use of my container. So how do I deal with that? Well, here's the solution for that. Another concept. I don't want to get too technical over here, but the idea is, I'm going to use MongoDB because it's very partitionable over here. Mongo as an example over here. I'm running the Mongo in a container. If I'm doing this for development, one instance adequate. If I'm doing this in testing, one instance is adequate. And in development testing, if my database gets wiped out every time I restart it, chances are that's okay. I want a clean slate anyway. In prod, on the other hand, not only do I want to have multiple instances of Mongo running, as many instances as I want. It is designed to be highly partitionable over here, so run many instances on commodity hardware. But what about my databases themselves? All right, especially since they'll be distributed across those nodes. I don't want it to happen where if one or even all those servers go down, I lose everything. So the solution to that is to use what we call a volume in Docker. What is a volume? You could see it as a disk, a logical disk that you create in Docker, and you are going to connect your containers, any containers that needs persistence, like databases, let's connect them to that volume. And what they can do now is they can start writing their own database files to that volume over here, which will be persistent. So if one of those containers go down, not a problem. We can bring it back up. It'll be a clean slate, right? None of the execution from before, any changes we might have done from the disk will not be carried over. But I'm hoping you see the advantage over here that with a volume, then the database server will just reconnect to its file in the volume. It is designed to be persistent. It is designed to be backupable, whatever we need to do over here, reconnect to the volume, pick up its data, and continue where it left it off. I can have multiple volume, of course, if I wanted to. So yes, it's perfectly fine and even desirable to run database servers in containers, but now we need to concern ourselves with volume. How are we going to concern ourselves with that? That's certainly a discussion I want to have for you guys. But let's expand that a little bit. Actually, I'm going to grab what I've done over here. Oops. Can I grab it with that? So I'm trying to figure out what I have to do with that dude. Boom. So grab what we've done over here, and I'm just going to move it. Oh, come on. And let's move it over here. A reason why I wanted to move it over here is let's move this into production now, operation. And let's over here, I've got my MongoDB cluster. And on top of my MongoDB cluster, or in front of it, let's say I've got a microservice application. And in front of that microservice application, let's also slap a load balancer, and then whatever else we may need over here. So load balancer that can distribute the load between my different services, and those services can, of course, talk to MongoDB, and we'll establish multiple connections. Going to get a little bit messy over here, but we've got multiple connections to our Mongo servers over here, distribute the load, etc. So cool. We've got a multi-tier architecture over here, a bit of a microservice architecture. How is Docker going to help us, or containerization going to help us when it comes to operating this? There's going to be some complexity to consider when it comes to that, but complexity we are going to encounter whether or not you use containerization or virtual machine, or you're running it on bare metal, doesn't matter at this point. So what do we need to concern ourselves with? Well, if this is a, let's say, RESTful type of application, and I've got another application over here, that application wants to issue a request to my microservice application. Could also be a web application, HTML application, doesn't matter over here, but we want to send a REST request to that application. It needs to be discoverable. Typically, we're going to do that via DNS, domain name services. I provide a domain name. We could also do that by IP address, but that's harder to skip. I need it to be load balanceable. I need it to be monitorable. I need it to be self-healing. I need it to be stateless, as we hinted at previously. And there's other characteristics I'd like to bring for that application, characteristics that are desirable in most environment, in most production and development and testing environments as well. So to make it discoverable, that would imply, if I'm going to go the DNS route, I would need to set up a DNS server, register the name of my load balancer and whatever else I have over here. I also need to actually worry about network path. network path, and security, firewalling, controlling access to resources. And actually, I'll just add that over here, firewall. These are concerns that we have for pretty much all applications out there. Load balancing, so I need to provide a load balancer. We'll talk about how Docker can help us with that. Make it monitorable. All right, that whole architecture over here, I want to be able to monitor it. I want to be able to monitor it real time. I don't want to just write log files to disk and then respond when something goes wrong. I want to start streaming those logs. So I probably want to have a log streaming service. And to do that, I may want to have a log streaming service sitting side by side with my microservices instances over here, log streaming service, where the application can write to that service, and then the log streaming service can then fire it to, let's say, a Kafka instance to start streaming my logs, and then incorporate that in my dashboard, incorporate that into my real-time analytics, my IDS, SPS, whatever else I need over here. Self-healing. No matter how hard we try, things are going to go wrong. Could be because of a hardware failure, could be because software failure, could be because of bug in the application. It don't matter. What matters over here is things may go awry. So if one of my node goes down, the ideal over here is I don't just learn about it, but that by the time I learn about it, boom, it's back up. Stateless, I've already talked about. All right, let's not maintain state on those machines. Make them on those containers. Make them so that when they receive a request for whatever operation, they perform their work. If they need to work with other resources, distribute the work, send RESTful requests, whatever we need to other resources, send back a response. We're done. All right, we maintain no state over here. Wash our hands off of it. We're good to go. And then we've talked about things like network path. For example, I need to ensure that this service over here, let's call it service B, can discover service A, its load balancer, and the load balancer can send information out there. So how would we manage that? Well, some food for thought for you guys. Using containerization can provide value over here, just raw containerization. One example, and this is a textbook example that I'm describing over here, the load balancer that we would install over here, which would really be a reverse proxy, if you're familiar with that. What is the most popular reverse proxy for HTTP application today? If you're not sure, we're talking about Nginx. What is Nginx? It's a web server, a very, very popular web server. I forget which one's most popular, Apache or Nginx today, but they're pretty much neck to neck today. And what I'm getting at over here is to do that reverse proxy load balancing over here, I would have to install Nginx, configure it, operate it, maintain it, etc. Oh, wait a minute. We're here to talk about containers. To make it easier for us, how about starting with the practices that we've talked about previously? Look for an Nginx container over here. Oh, it's right there. Nginx, yeah, boom. And oh, it's a Docker official image. So chances are, hey, I can certainly trust it. And it's one of the most downloaded ones. It has 1 billion downloads. Fair amount of downloads. All right. So it's a very commonly used, reverse proxy. All right. Most site. Actually, let me give you a practical example over here. Let's say I want to check out the news over here. I'm going to check out the CBC's site over here. Cool, there's the news, excited about that. But if I take a look at my networking tab, take a look at the original HTTP request, take a look at a response from the server. The server is going to tell me, hey, we're running Nginx. You can see that over here, maybe a bit small on your screen, but I can see over here, it is telling me we are running Nginx. Is that really what the CBC is using to dynamically put together their homepage? Well, the answer is no. And I don't work for the CBC. I've done some work for them probably over a decade ago before the architecture. I think I'm 2 or 3 architecture behind now, but I'm willing to bet that no, this is not what they're using to run their server-side code, but they're using Nginx as their reverse proxy. So any HTTP request that comes into the CVC lands in Nginx, and then Nginx dispatches the request to the right service. So how are we going to set this up? Well, we're going to set it up the same way we set up our Java code or our .NET code or whatever it is that we're working with. Going back to that example over here, what I would do over here is I would treat this as its own development project. I'm not going to write programming code. I could if I wanted to, but I'm not going to write programming code. Instead, I will, let me go back over here, rewind that a little bit. Instead, I'm going to treat it the same as any development project. We need to have a load balancer over here. So it's going to be its own project. Let's say we need to change this configuration, lands on the team that is responsible for load balancer. We acquired the code for that project. Ooh, what code are we talking about? Well, at a minimum, 2 files. An Nginx configuration file describing how we're going to route requests, the reverse proxy itself, security, and whatever else we're going to put in place. And the second file, at a minimum, would be my Docker file. I'll show you that one later on. So we make the necessary modification to our Nginx configuration. Boom, that's my work. Push it back. Go back to the pipeline over here. Pull the code. Rebuild the container that contains Nginx. So push the configuration to Nginx, run through a battery of automated tests, make sure that our routes are correct, that HTTP requests are correctly routed with the rules that we've put in place. Get into, there we go, pushing the package to Nexus. We've talked about that. Deploying, applying the changes in production. That would be an example of how we could do that via container. And there's more I want to get to as we carry along when it comes to that particular scenario, but let me put it aside for now. So we could use containerization, not just to host our code, the code that we develop in-house, but to host any components of the system that participates in one form or another with that system. Another example over here is I've got my microservice over here. I'll label those as microservice. Beside them, they have another container, which would be the log service over here, running side by side. It would have to run on the same machine. Actually, I'll need to group them together. That's another important consideration over here, where that microservice can't really be operated if the log streaming service is not accompanying it. It's 2 different programs, but they need to run together on the same machine. They need to be able to see one another, exchange information, one another. The microservice needs to send information to that log streaming service. I don't want this to go through the network. I want this to go through the local host, but keep them isolated nevertheless. So I'm going to put them together in what I'm going to call a pod. What's a pod? It's not an acronym. It just means I'm going to put them together in one deployment unit, meaning that when I deploy my microservice, and when I bring up the microservice, I need to bring up the microservice and the log streaming system. When I bring down the microservice, I need to bring down the log streaming system as well. So they come up together, they go down together. Sounds a lot like what I proposed earlier with Docker Compose. And you could consider using Docker Compose, but let me propose an alternative to what we're looking at. You want to achieve all those wonderful things that I've proposed over here, all right, for your load balancer, your pod, and whatever else you have in here. Would it be nice if we had an enterprise scale solution, a tried and tested solution that would make it possible for us to achieve all this out of the box? Docker doesn't do that, but many organizations have struggled with that. One organization in particular, you might know the name, it's a little company by the name of Google, who can claim to have the highest number of containers running on the planet, largest data centers on the planet out there. I mean, Google is almost the internet, for better or for worse. I'll let you decide what you think. But what I'm getting at over here is no company comes close to the amount of containers that Google is operating. And yes, they are using Docker. To make sense and to make the myriad of containers that they have manageable. Actually, let me add another characteristic over here. It also needs to be scalable. All right. In the case of Google, what if there's a sudden spike in demand for one of their services? Well, we need to scale it, ideally automatically, add additional instances to receive additional workload, right? So that's another requirement. Make the services discoverable, load balancing, monitorable, self-healing, all those things that we've talked about previously. Well, Google developed an internal tool, originally called 7 of 9, that worked marvelously well for them. It made managing their complex, massive infrastructure quite manageable, and they were kind enough, once the solution was mature enough, to release it. And some of you probably know what I'm referring to over here. What I'm getting at over here is a tool called Kubernetes. And here's the last piece in the puzzle that I want to put together in this presentation. Kubernetes is the tool that offers all of this out of the box. So what does Kubernetes do for us? Well, actually, to run Kubernetes, you run it in a container, all right? So very easy to bring up. For the developers in the classroom, or for those of you who want to play around with Kubernetes, you want to learn it, you want to explore it, you want to use it with your application at work, not in prod, but in development, in testing, there is a tool, I'm just going to share that with you guys over here, called Minikube with a K. And there go, install Kubernetes with Minikube. That looks like, okay, no, I want to get the English version. And install tool, there you go, there's Minikube. I'll bring you to that, share that in the chat window. I'm not saying you have to use that, but I would recommend you take a look at that. It runs on, as you can see right over here, Linux, Mac, Windows. Choose your favorite operating system, not a problem. Because Kubernetes requires Docker, installing Minikube also gives you Docker on your machine. Now, it does require a bit of juice. It is using virtualization, 2 CPU or more, 2 gigs of free RAM, 20 gigs of disk space, plus more as your containers grow over here, but you can always delete them afterwards. And it does run in a virtual machine. You can run it, for example, on VirtualBox, my preferred go-to when it comes to desktop virtualization, but you've got choices. How do you install it? Well, again, depends on your operating system of choice, but it should be reasonably straightforward. If you have any questions, let me know. This is not to install Kubernetes in prod. Running it in prod is a slightly different story. I'm not going to get into that in this session. That's an operational thing. But once you've got it up and running in prod, the idea now is I have a solution that can do all of that for me out of the box. Now, again, sorry, I'm going to have to put in a plug. If you need more details for Kubernetes, we've got excellent courses that get into that as well. So for those of you who want to understand how does it work, how to use it, I'll hit a little bit at it as we carry along, but that's the tool to use. There are alternatives to Kubernetes, right? We could talk about, for example, Docker Swarm, which is one of its alternatives. Realistically speaking, Kubernetes is more or less the industry standard. But there's a couple of reasons why it is the industry standard. It was developed by Google, and I think that's important over here to recognize. It was not developed as an academic or commercial project. It was developed to host literally the world's largest container infrastructure. So if it's good enough for Google, it's good enough for all of us, right? It's going to scale up to whatever level we need over here, making our container infrastructure much more manageable than the alternative. Of course, we could look at alternative, but another thing to consider, similar to Docker's and alternative, is that because it is more or less the de facto in the industry out there, you've got tons and tons and tons of resources to get you started with Kubernetes. And if you need expertise as well out there, consultant, staff, whatever the case may be, you'll have a better chance of finding folks who are already familiar with Kubernetes than with, say, alternative. So again, food for thought for you guys when it comes to that. I don't want to discourage you from looking at alternatives, but being realistic a little bit over here. And one more thing I should mention, I am an employee of WebAge, all right? So yeah, of course, I'm gonna encourage you guys and certainly welcome you guys to take our course. There's a couple of names I recognize in here, so welcome back. If you've never taken training with us before, hope you take the plunge. But beyond that, I am not associated with Docker. I am not associated with Google. I'm not associated with Microsoft, that sort of thing. I do a lot of work with their technology and even work with those companies from time to time. But again, there's no vested interest. When I'm saying go with Kubernetes, go with Docker, I'm not saying that because, yeah, I'm going to make a comeback on that. No, not at all. All right. So just want to make it clear for us. So let's wind things down with a couple more demonstration over here. And I want to come back to my little diagram over here. Actually, let me clean that up a little bit. It's getting kind of messy. And going back to the original scenario, I've got a development endeavor, I've got a production environment, I've got a tool to manage requirements, and a request comes down the pipeline. And we want to work with containerization. And to highlight also some DevOps principle. What could that request be? That request could be, of course, let's add a new feature. And we kind of walked through that earlier. That request could also, let's fix a bug. And the process would be the same. What if the request is security? All right. Let's say, for the sake of that discussion, we're using Tomcat as our application server. And we get a security advisory from Apache saying that we found a vulnerability in the version of Tomcat we are using. And the way we're using Tomcat is that we're using, going back to our whiteboard over here, I've got an application over here, uses Tomcat, Apache Tomcat. If you're not familiar with Tomcat, don't worry about it. That's just an example. Tomcat version, whatever, doesn't really matter, all right? And we put the whole thing in a container. I get a security advisory, that version is compromised. There's a problem with it. Ooh, I need to fix that ASAP. I need to fix that yesterday. So how are we going to go about it? Well, if we're doing things traditionally, what does that mean for us? Well, it means that I would need to go through every one of my production machine that is running Tomcat and upgrade them to the latest version of Tomcat. If I'm not using virtual machine, I would have to go to the native machines and upgrade to the latest version of Tomcat. A bit of a manual endeavor. Yes, it can be updated. It can be automated, but it's a manual endeavor. So how would we do this in a DevOps/containerized approach? Well, the team receives the request, we distribute the work, we clone the code over here. Notice I'm not dealing with anything in production over here, so I clone the code. What do I do with that code? Well, in that code, whoever has the necessary expertise is going to look for a file called Docker file. That's literally the name of the file. All right, Docker file, capital D, the rest in lowercase. So we look for that file. In that file, well, here's the file itself. I say a statement, use Tomcat version whatever. What I do over here is I go to Tomcat version whatever and replace that with the version that fixes the security issue. That's all I need to do. Save the file. So that's my work, save the file. Push the modified code back to the repository. This is going to bring it to my CI/CD pipeline. Oh, sorry, one thing I should have done over here, a step I skipped over is that, okay, I modified the Docker file. Something else I'll also need to modify, and actually I should have done that before. I'll need to modify the test case, so add a new test case to make sure that we're using at least the corrected version of Tomcat. I want to make sure that this is correct. I maybe even write a test case to make sure that we're not vulnerable to the security issue that has been found. So I push this, run my pipeline, pull the code over here. As we've talked about previously, do a full rebuild. Now, what's going to happen is when we rebuild our container, we're going to go back to hub.docker.com or our Nexus repository and acquire the updated image of Tomcat. Go through the test, which should include tests to make sure we're not vulnerable for that vulnerability, and that we're using the right version, whatever test we want to run. And then we prepare the package, poof, push it into our registry, deploy. Now, one thing I kind of kept quiet about, you'll notice when I do my deployment over here, there's that funky thing over here, kubectl. What the heck is that? Well, kubectl is a command line tool to, guess what? Manage Kubernetes. So the pipeline over here would issue a kubectl command telling the production environment, okay, go ahead and deploy or apply those changes to the environment. So as part of those changes, we've got a new version of our microservice, whatever was using Tomcat over here. So Kubernetes over here downloads the new version of our image with the version of Tomcat that has been fixed, security issue address. We never had to touch the production environment directly. In other words, at no point did a human being needed to go into the production environment and start manually connecting to those machines, doing updates, upgrades, whatever the case might be. Fully automated process. So we are getting into DevOps type of principles over here. So let me go back to some of the questions. There's a couple of questions over here. Good question. Is centralization right for any business problem? We have CMS system and managed customer data over a long time, and the data state will affect functionality. So that's the first question. How do we share database between containerized services? All right, good question. Couple of answers I'd like to suggest for you. Centralization, right, for any business problem. I don't want to make it an absolute, but the reality over here, especially when it comes to big data, decentralization is more what we're looking at. Unfortunately, using a CMS encourages centralization. Don't want to say that's necessarily a bad thing, but it will limit your agility. And one thing to recognize about data, especially big data, is that data outlives application. As a rhetorical question, I would say the data that you have in your CMS, which system did it come from originally, and how many systems has it gone through as of yet? That's a rhetorical question in the sense that chances are a lot of your enterprise data, especially if your business has been around for a long time, has gone through many systems. So will this affect functionality? Because many CMS are built monolithically, it's possible to run it in a container, might ease the operation of your CMS, but it's not going to give you a huge advantage. Yes, some of the advantage to that, but not a huge advantage. Also, how do we share database between containerized services? That's also a really good question. It's more of a microservice question, but let me give you the answer I'd like to propose for that one. The short answer is If you have a microservice, and it could be multiple instances of that same microservice, let's call it microservice A over here. If that microservice needs to persist information, provide it with a micro database. Now, you may or may not be able to do that with your CMS, and I'm not saying reinvent the wheel, start changing everything towards that, but as we move ahead, let's consider re-architecting our microservices or moving towards a microservice architecture and organize it in a way that the microservice as a whole, not the deployment unit, but the microservice as a whole, what the team is responsible for is the code for the service, its endpoint for the service, REST, so whatever you want, and of course the database in the backend. And going back to the original question, strong suggestion, this database is fully, wholly owned by that service. No other services have access to that data. Now, at first it may seem constraining, especially if you're accustomed to big, massive enterprise databases, but there's strong disadvantages when it comes to that. So a question that often comes up at this point, there it goes, I've got microservice B over here. Microservice B needs access to what we have in that database. Our knee-jerk reaction is, oh yeah, let's just allow it to get to that database. What I like to recommend that we do over here is let's walk away from that knee-jerk reaction and instead make that business data available through the endpoint instead. So change in culture, and at first, again, it will make you a bit uncomfortable. Some concerns I get about this is, what about joins across different tables? What about performance? Now I need to hit different systems that each have a source of the information. What about analytics? All right, generating cubes, OLAP cubes based on my data if it's scattered all over the place. How the heck am I going to do that? Well, food for thought. In terms of performance, believe it or not, you'll probably get much better performance with micro databases than enterprise database. Why is that? Well, a couple of points to consider for us with a micro database or with an enterprise database where I have multiple applications. All right, so that would be server application A, application B, application C. They're all using the same database. We're all hitting that big fat resource concurrently. Here, we should get much less demand on that service because it's a little bit more specialized over here. And the database itself will not be as vast and as encompassing as the big one that we have over here. Thus, the load will be lesser if we have multiple smaller database. Second advantage that we have over here, and the important one, is agility. Things change. I doubt you would be here right now if you didn't recognize that things changes in your environment. And one of the things that is unfortunately a detriment to our agility, that really stifles our agility as an organization, are those big, massive enterprise database. If I were to ask you, how easy is it to make changes to your enterprise database? Adding new table, adding fields, changing constraints. Probably very difficult, because if I make a change, let's say to service application A, who knows what the impact will be on application B, application C. If I abstract away the database over here behind a service endpoint, whatever endpoint I want to use, then it means I can keep the endpoint stable and change the database as I see fit. It's only used by one piece of code. As long as that piece of code is stable, I'm good. And there's other advantage to consider. I'm no longer locked in one type of database. If it makes more sense to use as opposed to relational database, if I want to use a document database, I want to use a graph database, an object database, a column store database, a key value pair database, whatever type of database, I now have that flexibility, especially if I'm working with cloud solution. And if you want to consolidate data, the approach that we're often going to use over here in the industry, just food for thought. I'm not saying that this is a full solution, but food for thought to consolidate data for analytic use. Instead of connecting again directly to your backend database, have the service issue changes to a streaming service like Kafka. Kafka is another open source project by the Apache Foundation, commercially supported by Confluent if you're looking for commercial support. But we could use a streaming service over here and use that to start building our analytics cube over here in a more predictable fashion based on what we have over here. And I can integrate that with cloud solution, AWS, GCP, Azure to achieve the same end with less infrastructure at my end. All right, so going back to your question, it's a good question. Is centralization right for any business problem? The answer is going to have to be it depends. If all things being equal, I have a choice between centralization and decentralization. Even as a knee-jerk reaction for me today, I'm going to favor decentralization. And just so you don't think, oh yeah, that's JF personal opinion, to some degree, yes. But when I started my career, 1990s, I used to strongly favor centralization, big system, monolithic system. Today, I would feel dirty defaulting to that. So I don't know if that helps answer your question. If not, please let me know. But I'm hoping it helps answer your question. And I get another great question over here. How do you version control the Docker containers themselves? Well, two files you will need to version control your Docker file. Your Docker file over here, do that in Git. That's not your container itself. Your container, use a tag to version it. Let me show you. Instead of just talking about it, let me switch over to a quick example. I'm not going to spend too much time on that. Boom, there we go. So what I have over here is a Java application, and in here I happen to have a Docker file. All right, what am I doing with that Docker file? I'm not going to go through the full detail over here. I don't want to get too technical, but you'll notice at the top over here, I am saying from OpenJDK : 11.0.8. That's a tag. Now, I'm not using that to version my work, but I'm using that over here to indicate here's the version that I want to use of that of the OpenJDK image. And again, we don't call this a version, we call this a tag because it doesn't have to be a version itself. Now, what I can do, actually, let me just confirm where I've put this one. So downloads HR system, let's go there right now. Actually, I'll exit out of here and let's go into downloads, HR system. And in here, actually, before I do anything, I do believe I've got a, no, it's not that. So if you take a look at my list of images, you'll notice there's no image called HR system. Let's create it. If I take a look in this directory, oops, HR system, in this directory, there's the Docker file that I've shown you just a moment ago. So you should recognize it over here. That's the same Docker file I had on the screen. Let me build my container based on that. Docker build. I'm going to give it a tag. And that's going to answer the question over here. How do you version your container? You use tag. So I'm going to call this container HR system : and the tag I'm going to use will be, say, v1.0, whatever you want. It could be a full tag, could be a date, it could be a hash, it could be whatever you want. So in that case, I'll just call it v1.0 and I'll say use the local Docker file, give it a second or two. So you'll notice over here from JDK8, and then it goes through the steps over here. Whoop, copy fail, I may have to build. Whoops, the code over here. May have to do a Spring Boot. I'll do a run, make sure that I haven't broken anything. Just going to give it a moment or two to build the system. I'm not using a two-stage build like I've talked about previously. And so it looks pretty good. It's starting the application. Done. I'm actually going to stop it. Let's redo it. And copy failed. No such file or directory. Why is that? Let me take a look at my Docker file. Make sure that this does exist over here. Oh no, actually, sorry. I see what I'm doing over here. I need to do Maven package. So that actually creates the jar file. That's why I can't find it. There we go. So here's the file it was looking for, the jar file. This is an executable in the Java world. Let's try that once more. And we're good. There we go. I've created my Docker image. I can see it over here. There's HR system, tag 1.0. Let's say we create a revision. We fix a bug, whatever, right? I'm going to change, let's say, something in the code. What do we have that's of interest for us? Let's say I'm going to change the path over here from employees to employee. Minor change, doesn't really matter. As part of my pipeline, I would rebuild the container, but change the tag. So this is where I might use, again, a timestamp. I might use a incremental number. I might use a hash generated value. Doesn't really matter. Let's regenerate it. Boom, it's done. Let's do a Docker images. Now I've got two versions of that image, 1.0, 1.1. So now I can specify exactly which one I want to run at runtime in my production environment, even in my development environment, in my testing environment. So going back to that question, how do we version control of the Docker containers? When it comes to the Docker file itself, that file that I've shown you over here, it's just code. It's not programming code, but it's just code. Store it in your repository, your code repository. When it comes to versioning your container, use a container registry. You could use hub.docker.com, or you could use Cloud Solution. For example, I could go to, say, Azure. I'm going to crack open my Azure portal over here. Boom. Let's log in quickly. Sure. And I'm just using Azure as an example. I could do the same with GCP. I could do the same with AWS or other resources. Over here, I need a private Docker registry. See if I can find it for you quickly. Container registry. It's right there by Microsoft, right? So I can use Azure to host my containers themselves, right? Push my images to that registry, pull images from that registry for my pipeline, for my dev environment, for my prod environment, whether it's on-prem or in the cloud, doesn't matter. Even if I'm doing this through AWS, through GCP, it doesn't matter. Another great question. If you were using Docker in your development environment, would you be able to integrate it easily with your IDE, for example, IntelliJ? Well, I so happen to have IntelliJ over here. And I love that question because if you know your IntelliJ, if I go into my build over here, let's go to actually, I'll go into run configuration or build. There you go, edit run configuration. So how do I want to run it? Well, if I go over here, my plus already configured in my case, do you want to run it through a Docker image? Do you want to build it and run it through a Docker file? Do you want to use Docker Compose? So how well does it integrate? It's a good question. I'm glad you asked it, and I'm hoping that it answers it for you over here. Most IDEs, Visual Studio Code, Visual Studio, IntelliJ, and the JetBrains IDEs, Eclipse, name your favorite development environment. Today, they all support containerization. Sometimes through plugins, most of them have it built in. So again, a good question. I'm hoping that it answers it for you as well. You guys are asking a lot of good questions. I really appreciate it. But I'm noticing the time as well. It's getting dangerously close to 1 o'clock. We've covered a lot of good ground, and I certainly do want to thank you for taking time away from your busy day on a Friday on top of it all to join us for that seminar. I'm certainly hoping you had as much fun with it as I did presenting to you those technologies. There's much more I would love to discuss with you guys. And again, I'm going to plug a little bit over here. If you want more detail, 3 hours is not enough to cover everything, certainly not getting into the more technical side of things. We at WebAge have custom courses that we develop and have delivered to hundreds, thousands of participants around the world when it comes to containerization. So if you need more detail, I certainly hope you will consider us when it comes for that. But to wrap things up, I'm not kicking you guys out. If you guys have any additional questions for me, stick around. I'll be happy to answer them. But if you would be so kind, there's one last thing I would appreciate that you could do for me, and that's an evaluation. We do take the quality of our seminars as well as our courses very seriously. So if you could take a moment to fill out our evaluation, I'll give you the site over here. It's webagesolution.com/eval, webagesolution.com/eval. It's in the chat window. You can just click on it. It will ask you for a course code. The course code that you will need is the following. Course code. There it is in the chat window. So I can just copy and paste that over. Boom. Looks like I've got a apostrophe over here. And if you could do a final evaluation for me, that would be greatly appreciated. I'm not kicking you guys out. For those of you who have additional questions for me, scenarios you want to discuss, stick around. There's a couple of minutes left. Otherwise, again, thank you very much for joining us. Hope you guys have a fantastic weekend. And if and when you start using Docker, I certainly hope you and your team has as much fun with it as I do. And at this point, I'll deem the presentation officially over. Oh, wait, I've got a question over here. All right. You mentioned a while back that desktop application won't run in container or shouldn't run in container. Sorry for the new question. No, it's not a new question. It's a very important question over here. One of the reasons, well, the reason is they're designed to run in isolation from the system. And to achieve that, they actually run in a separate user account than your account themselves. So you would not see them on your screen because they would not be running under your credential. And also because they run in isolation, very often they may not have access to, for example, X technology to display things in Linux, or some of the GUI APIs that are available in Windows. From the perspective of the application, it would look like they're running in a Windows core, Windows Server core installation. So if you wanted to, there are ways to tweak the application and the environment to run GUI application in Docker, but more likely than not, what we're going to do is we're going to run a web application to Docker. So after we start the application, we go to our web browser, localhost : whatever port, and then connect the application. That's a more traditional way of interacting with it visually from a GUI. So good question. Thank you for asking. Hoping that it helps answer it. And again, don't be shy for your question. Whether you feel it's a new question or not, it's probably a great question. And I see a couple of you, thank you very much. Again, I do appreciate your feedback. And as a reminder, if you could do the evaluation on the way out, it's always appreciated. And one way or another, I hope we're going to see you again at our next seminar. I think you know that we run seminars and even some free courses from time to time. You should be registered through our email newsletter. Keep an eye out on those. Myself and plenty of other presenters, great presenters, are available to those. Take advantage of that. I'll hang around for another minute or two. Again, if there's anything else I can do for you, let me know. All right, it's just about 1 o'clock. Just a handful still online. Yeah, so if there's any other questions, leave them in the question window. Otherwise, I'll be closing thing in a second or two. Again, for those of you who are still online, thank you very much for joining us again today. Hope you have a great weekend.